Hey guys, Professor Calculus is here, and today in this video I'm here with solving this integral here. Before that, make sure to like and subscribe, and as it is free and you can always change your mind later. So, to solve this, I'm gonna use Feynman's trick, which is not necessary but is really interesting. I'm gonna define a parameter a in this integral, and if I find I of 1, that means that I have found the integral that was asked. So now, as usual, let us take the derivative, total derivative, with respect to a of the integral from 0 to 1 of ln of xa plus 1 over root x dx. Okay, doing so would require me to do a partial differentiation, partial a of ln of xa plus 1 over root x dx, and I prime of a is gonna be 1 over xa plus 1 according to the chain rule times x over root x, and x over root x is the same as square root of x according to the laws of powers. So now here I can use the integration by parts, and that says that if I have a function u dv, I'm gonna call this one dv and this one u, and can write it as uv minus v du. U is root x, which means u is x to the half. Du is half x to the negative half, which is 1 over 2 root x. dv is xa plus 1 over v, therefore according to chain rule is ln of xa plus 1 over a. So doing this thing here would give me u root x, v, this one, ln of xa plus 1 over a, and minus the integral from 0 to 1, half du, half x to the negative half, the duv, ln of xa plus 1 over a dx. I prime of a, if I do the limits here, it's gonna be ln of x, ln of a plus 1 over a minus 1 over 2a, ln of xa plus 1 over root x dx. So now notice that this thing right here is our I prime of a. If you look closely, sorry, I of a. So this is I of a. I prime of a therefore is ln of a plus 1 over a minus 1 over 2a I of a, and I of a is defined as this one, and you see that is the same as this one here. So I prime of a minus ln of a plus 1 over a equals negative 1 over 2a I of a. 1 over 2a I of a is I prime, ln of a plus 1 over a minus I prime of a, and if I let a equal to be 1, I'm gonna get I of a over 2 equals ln of a plus 1 minus I prime of 1. I of 1 therefore is I of 1 is 2 ln 2 minus 2 I prime of 1. So what is I prime of 1? I prime of 1 Now it's I prime of t is the integral from 0 to 1 of root x over xa plus 1 dx, and I prime of 1 is root x over x plus 1 dx. Now I'm gonna let u be equal to root x, u squared is x, 2u du is equal dx, so I can replace it with dx here. And if I do this thing here, do this substitution, the integral from 0 to 1 of, I'm gonna get 2u squared over u squared plus 1 du, which is gonna be this thing here. Now how do we solve it? Well, we can add and subtract a 1 here, so we've added 0. We're allowed to do that in math. So it's gonna be 2 the integral from 0 to 1 u squared plus 1 over u squared plus 1 minus 1 over u squared plus 1 du. So this is going to go down to 1, so it's going to be 2 minus 2 arc tan of u, this is the integral of this is arc tan from 0 to 1, which is 2 minus 2 arc tan of 1, which is pi over 4, and we're going to get 2 minus pi over 2, which is our I prime of 1. Now let's see our equation here. Where was it? I of 1 equals 2 ln 2 minus half minus 2 I prime of 1. I of 1 therefore is 2 ln 2 minus 2 times 2 minus pi over 2. I of 1 is 2 ln 2 minus 4 plus pi, which is, I can use the property of logarithms and write this as pi minus 4 plus ln 4. And we found our I of 1, which is the integral from 0 to 1 of ln of x plus 1 over root x dx, which is equal to pi minus 4 plus ln 4. And that is the final form of our integral. Obviously there was easier ways to solve this integral, but I wanted to show this really clever and interesting method here. Just you see how powerful Feynman's trick of integration is. Don't forget to like and subscribe, and I'll see you next video.